I just want to remind you guys of the basics. So make sure, guys, whenever you start a lesson, you got a pen, you've got a book, you're sitting at a table, you're ready to work. Because it really is important you're active during these sessions. I think you all know that, but I just want to remind you. And then I also want to remind you, a lot of students often ask about, can you help with this topic or that topic? And obviously in this unit, we're focusing on a particular exam topic, but guys, we've been doing this for a while. So if you look at the Watobe website, just to show you, if you go there and you click on classes, you're going to get the grades, and you click on grade 11, what you're going to see is a whole bunch of stuff that we've done previously. And so if you're struggling with a particular topic, don't forget we've got those resources for you to hopefully help you. And I just wanted to make you aware of that. Okay, then the other thing for today is guiding questions. So I like this idea of setting our agenda. So the guiding questions are, can you work out the angle of inclination of a straight line for both positive and negative gradients? And then if lines are perpendicular, what does that mean about their gradients? And so I'd love if you guys can just put in the chat, what do you, as we come to these questions, what do you know about them already? Do you know anything about them already? What do you know about working out the angle of inclination of a line? Just put it in the chat. What do you know about lines that are perpendicular? I'd love to see in the chat what you guys know already. Perpendicular are not the same gradient. Yep, that's correct. And then what else? So does anybody know anything else about perpendicular? And also, what about, are there any formulas that we need to remember for angle of inclination that might be helpful? Okay, so Nalotando said lines that are perpendicular, the product will be -1. Yeah. Tan theta is involved. Yes. With my angle of inclination, tan of theta equals m. Yes, that's important. So at the end of the last lesson, that was kind of where we left off. All right, fantastic. Okay, so let's go from that. Oh, the power just came back on, but we'll stay in our current setup. So what I want to do is I want to start with this question. And what we have here is we have a straight line. And in the last lesson, I told you that to work out the angle of inclination, we use this formula where m was the gradient and tan of theta was a trig ratio from trigonometry. And we talked about this angle over here being the angle of inclination. And so I want you guys to start by working out this first one for me. And I'm going to turn my lights on just so. Because Eskom has brought the light back. Thank you, Eskom. All right.
Welcome to the light.
Thank you. It's so much nicer having light. All right, so what do we got? So I want you guys to work out this blue angle over here. This is called the angle of inclination, and it is the angle that a line makes with the positive x-axis. And basically in the last lesson, we figured out that this formula comes from being sneaky and basically saying, look, this is a right angle triangle, this is O, this is A, and you can look at the previous video for that. But that's how we got this formula. But can you use it? And what do you need to find in order to use it? I'll give you a hint. You need to find the gradient. And for that, you need another formula. So see if you can use that, and then I'll wait for some answers in the chat. Can you also post your gradient, guys? What is the gradient that you get? I'm interested to know what the gradient is that you get. The other thing is you need to actually know what that point is. And so that point over there is going to be the point 0, -1. So if I do this, what I get, sorry guys, my Bluetooth is being very weird. 3 minus minus 1 and 2 minus 0. And 3 minus minus 1 is 4, and that's going to be 2. My pen is being very weird, but you do get a gradient of 2. Yes. And then if you sub that 2 into the formula, you get this trig equation. And to solve it for theta, you go shift tan 2, and you should get 63.4 degrees as that. Now, guys, I want to point something out to you, and this is important. This is a trig equation, and this trig equation has a positive value. Now, where a trig equation has a positive value, especially in this context, it's very, very simple. But we're going to be doing examples later where the gradient might be negative, and then it's a little bit more tricky. Not too much, but we just have to make a slight adjustment. Okay, so I just want to point that out. This was a positive 2, and so we got 63.4 degrees. Now, I want you to do this next one for me, and it's a little bit more spread out. Basically, what you're looking to find is this angle up here, and I'm not going to say more than that. I'm going to say, look, you've got 2 points on the line. Can you work out the angle of inclination of this line, which is going to be this angle up here? And see what you can do. Hi, David. No problem. Jump aboard the bus. You can join us. We're doing angle of inclination still. And in these questions, we need to be able to use this formula. And in order to do that, often we need to find this. So that's where we are. Okay. So just restart my there we go. So we should get for our gradient, you can do this in whatever order you like, as long as you're consistent, 1 minus minus 9 and 2 minus minus 3, which then gives us positive 10 over positive 5, which is 2 again. My goodness, what a coincidence. Which means that it's going to be the same answer. Yeah, because you've got the same equation, so you must have the same answer. We have 2 equals tan theta, and so theta will be 63.4 degrees. So that's just saying this angle over here, that the angle that goes from the positive x-axis, it's going to be 63.4. Okay, so I kind of feel like, you know, most of you seem to be okay with this, and so we need to look at the case where it's a negative line. So let's go to that. Give me a thumbs up if you're comfortable with this before I move on. Just want to check. Okay, and then apologies for the siren in the background. I didn't quite know what's going on there, but okay, fantastic. Okay, so let's go to a different scenario. Let's go to example number 3.
Well done, guys.
Well done, yeah. So if I want to work out the angle of inclination here, there's actually a slight catch, guys. There's a slight catch. So I'm going to do this one with you, and I'll show you how to do it. And there's 2 methods, but I want you to just notice when let me just close the sirens are so loud. Let me just close my door. Okay, don't know. Hopefully it's nothing too important. When you have a negative gradient, what do you notice about the angle of inclination? I want you to, in the chat, what do you notice about when you have a line with a negative gradient and an angle of inclination? What's different to before? Yeah, we're going to do this now in a moment. But just before we even do that, what do you notice about it? If you compare it to the earlier ones, it's obtuse. It's the other way around. It's much bigger. Guys, you are on the money. Exactly. So what you'll notice is that if we just do it normally So let's do that. The first step is find the gradient. Okay, so we're going to find the gradient. Now, this point up here is the point 0, 2. And so I'm going to calculate my gradient, and I go 2 minus 0, and then I go 0 minus 6, and I get 2 over minus 6, or I get minus a third. Now, this is good news because I expected the gradient to be negative. If the gradient wasn't negative, my eyes are lying to me. But here's the problem. Okay, when I write this formula, so when I write my solving my formula, I get, if I do this, minus third equals tan of theta, it's not actually going to give me what I want. Okay, it's not going to give me the angle of inclination. I need to make a slight adjustment. And so to be consistent with how we normally solve trig equations, we always ignore the negative. And so what I'm going to do is I'm going to ignore the negative here. And if I ignore the negative, what happens is it gives me this angle over here. Okay, so I'm going to ignore the negative. And this is what I taught you with trig equations generally. But it's good when I ignore the negative, I'm going to get the reference angle over here. And what I really want is the green one. But we'll make an adjustment in the moment. So everyone, type in your calculators, shift tan a third. So we're ignoring the negative, and tell me what angle you get if you go shift tan a third. Okay, you get 18.44 or 18.4 degrees. Perfect. Now we know that that is not correct. At the moment, you can see the angle of inclination is this big green one over here. What you figured out is that what that one is. But there's a simple thing you can do to figure out the big green one if you have the little one. What do I need to do, guys? Okay. Reduction formula, exactly. Or even just think, what do angles on a straight line add up to? Okay, you don't actually add 180. So that's the other method, which I'll talk about in a moment, in case you guys, but basically, shouldn't I just go 180 minus 18.4? So I just subtract this, and whatever is left will be my green one, which is going to be what? So 180 minus 18.4, you should get 161.6 degrees, which makes a lot of sense when you look at the drawing. Now, guys, that's the method I would recommend so that we be consistent with the way we solve trig equations. And the way we do it is basically we say, look, whenever there's a negative, we ignore it. And then we just make an adjustment afterwards to incorporate what I call the reference angle. However, if you choose to leave the negative in, you will also get the right answer if you add 180, but that's only if you leave the negative in. And so what I'm going to recommend is that basically, let's be consistent. Let's stick with this method. We ignore the negative. We find our little reference angle, and then we have to go 180 minus that angle because tan was negative to start with, and tan, then it has to be in quadrant 2. Now, that sounds like a mouthful. It's better if we just practice it. So I'm going to go over the steps. Step 1 was find the gradient. Step 2 was plug into the formula, but we would ignore the negative. And then step 3 was basically to make an adjustment or make sure we were in quadrant 2, because tan is negative in quadrant 2. And if you've done the previous module, you'll know that all angles in quadrant 2 are 180 minus the reference angle. Okay, but I feel like I'm getting too wordy with that. Okay, let's do a practice example of this because it's better if we just do it. So I'm giving you this straight line with a negative gradient. I want you to work out the angle of inclination, which is this one. And I want you guys to try and do that using what I just did in the previous example. And I can even zoom out a little bit so you can, I think if I zoom out too much, it's going to make the question harder to see. So all I'm going to say is Step 1 is M. Step 2 is what I call find reference angle. Step 3 is adjustment. And just see what you can do. However, if you are stuck, put your hand up or unmute your, or I can unmute you and we can have a conversation while other students are working. Okay, so put your hand up and
do this, guys.
we can chat.
Gradient already.
You can tell brains are working hard.
Yeah.
So just mimic exactly what you saw in the previous question. Okay, I see some answers coming in, but I want to give a little bit more time for this. So I'm not going to be giving it answers away yet. But I will work out the gradient while students are busy. Sorry, guys, if I'm a bit messy tonight, I'm on a small screen. So one minus, and then 5 minus 1. So 4 over 4. So I get a gradient of 1. So then, oh wait, I've made a mistake, surely. 1 minus minus 3 is correct. And 1 minus 4, guys, I did a naughty one. Look at that. Look how quickly even the pros stumble into difficulty. I should go 1 minus minus 3, and then I should say 1 minus 5, which gives me minus 4 here and minus 1. So the gradient you initially get is minus 1. And I expect that because it's a negative, you can see the line is sloping down. Now, what's the next step I need to do? Well, because it's a trig equation, I'm just going to ignore the negative. And I'm going to say 1 equals, let's use a different color, 1 equals tan of theta. And I'm going to get my reference angle. And what's my reference angle going to be? Pop it in the chat. What's the reference angle? And this is not the angle of inclination. This is just the reference angle. In terms of this drawing, the reference angle that we're finding is this one over here. Okay, so I see lots of students are saying that the reference angle they get is 45. And then what is the angle of inclination going to be? The one that the big green one. So because tan is negative in quadrant 2, and because you can see literally, if you've got the red one, it's on a straight line, well, it's going to be 180 minus 45. And so the angle of inclination is 135. Yes, well done, Andile. Well done, Neo. You guys are awesome at this. Now, we're going to do one more example like this, but just give me a thumbs up if you feel comfortable and you feel like you're on the right track here.
I've been watching the charts and everybody just got like the right answer.
Okay,
like,
so
I haven't seen the wrong one. Well
everybody's
done,
on the right track. Okay, let's just do one more. If I see everyone's good, then we move on because clearly everyone's got it. So find me the angle of inclination of this line over here. This, yeah. And I'm not going to say anything. I'll wait.
Let's do this, guys. Y'all are awesome. You just got it right. Let's continue. Let's continue to do this.
Cool.
Please remember, if you are shy, I am here. You can chat to me privately and I'll try to help you as the best as I can. And you can also ask Teacher Peter if needed. So please do so. I hope everybody's understanding. I'm understanding. So I'm glad. Thank you, Teacher Peter.
Pleasure. Okay, let's do this bit. m equals. The biggest thing I have to watch out for is just switching my y's and x's around. That's the mistake that everyone makes, because you get tired and your brain just switches. So -6, 3 minus 2. So then we say, so what do we get for the reference angle shift? Tan 2. We're getting this a lot in today's one, 63.4, but that's not the final answer. What is the actual angle of inclination that we get? You know, what we've worked out, what is 63.4 is this thing over here. What I want is, sorry guys, I'm just going to abbreviate this because I have so little space to write on. So I should get 180 minus, okay, it depends on how much rounding, 63.4. I get 116.6. Fantastic. Okay, so you guys have done very, very well. In fact, you've done so well that we're ahead of schedule. And so I'm actually going to do another type of question. Well, I'm going to change. I think that you've all got this angle of inclination, and I would recommend go and look at, yeah, we can practice some more questions in the review lesson. But for now, let's move on. And yeah, shout out to you guys. Well done. That was very good.
Well done. Well done, guys.
Thank you. Okay, so what we're going to do is we're going to squeeze one more example in before our brain break. And so the topic is perpendicular lines. And I want to look at this particular graph that has two graphs. We'll call them line A and line B. And I want you guys to work out for me, what is the gradient of line A and what is the gradient of line B? I want you to work that out, and I want you to just use sometimes what we call the rise of a run method, or use whatever method you like. But I want you to work that out, and then I want you to see, what do you notice about the gradients? Or if you notice anything, I don't even know. Maybe there's nothing to notice. Okay, so I'll give you some tips. What I like to do is when I look at a drawing, I always look for a point where it goes through an exact thing. So maybe like for this one, I think those are good points to count. And so how much do you go down by? Ooh. It looks to me like what I would call the rise, that has to be 10. And then this has to be 4. So what does that mean about the gradient of line B? That's some tips. And then for this one, you could use a couple of points. I probably would just use, and I would say, well, what is the rise and what's the run here? And so what's the gradient? So that's just my little, whenever you see a drawing and you don't actually have points, you could work out the points and work out the formula, but sometimes you can just count. And so I'll wait a little bit more for students to put the gradients in the chat. I want to give a bit more time. Can you see okay, Yolanda? Is it clear?
Yes, it is clear. On my side, it is clear. Is it clear, everybody? You should be able to see every single number, every single point.
Okay, so what's the gradient of so far? I only see Bonga's answer. So for line A, for me, in fact, we could do it. In fact, instead of counting it like this, we could even count it. Maybe counting it like this is better. So we go. Might be easier to see this way. 1, 2, 3, 4. So 4 up, and then how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Aha. Okay. So what we see for line A, if I can't you see the bottom of the thing? I'll move. It's in line with, yeah, so it's 12 across 4. So I get the change for A, it's 4 over 12 or 1 over 3. So that would be the gradient I got for line A. For line B, what I get is I get, it's going to be a negative because it's sloping down, and it's going to be 10 on top, and it is going to be 4 over here. Now, negative 10 over 4 can also be written as what? It could be negative 2.5, if you like. Now, guys, earlier in the lesson, people mentioned this. If lines are perpendicular, when you multiply them together, you'll get -1. So what I want you to do is I want you to multiply these two gradients together. So 1 over 3, which is the line A, and minus 10 over 4 or minus 2.5. Multiply them together and see what you get. What do you get? So I'll even do it on my calculator. Minus 2.5 times by 1 over 3. And what I get is, yeah. So if you multiply them together, you get -5 over 6. Basically, if you multiply M1 times M2, you get about -5 over 6. Now, if these lines were perpendicular, when you multiplied them together, you would have got -1. So to answer the question, are these lines perpendicular? We would say no, because I'm just going to use the notation M2, M1. So no, because M2 times M1, or I suppose I could even say, since it was line A and B, I could say MA times MB does not equal -1. So these lines are not perpendicular. Okay, so that's it was a bit of a tough one to start with, but basically, if two lines are perpendicular, you would expect them to have a product of -1. Another way of saying it is we say sometimes they're negative reciprocals. Okay, but let's do another example just like this, just to help us here. So it says here that, what does this actually say here? Sorry. Okay, so let's actually do this. Before we even worry about perpendicular, let's go back into the skills from earlier in the section. Line 1, they give us the equation of y equals 3x minus 12. So that's given. Can you guys find the equation of line 2? Now, line 2, they give you 2 points. You can read off what those 2 points are. Can you find me the equation of line 2? And that's all I want you to do now. So I want you to find the equation for me of that green line. And I'm just going to zoom in a little bit so that your focus is completely on that. And all I'm going to suggest is that this point over here, do you know what that point is? And do you know what that point is? Can you read it off? Can you see the blocks, Yolanda? Can you clearly see the blocks so that no problem counting?
Yes, it is clear. I can see the blocks and I can
Okay,
count
so one of the
nicely.
most important skills in this section is just to make sure you can figure out the equation of straight lines And we did that in an earlier lesson, but I want you to see, can you do it from this sort of situation where the information is more vague? And I want to challenge you first, write down the points over here that are on the drawing. Oh, Bochlale is on fire. So first have to check your answer, but hang in there for a second. So this point over here, it looks to me like 0, 2, 3, 4, 5, 6, 7, 8, 9. This point over here to me looks like the point 9, 0. And so if I want to find the equation of line 2, well, whenever I find the equation of a straight line, I always have to find the gradient. And so let's do that first. So what do we have? We can say 0 minus 2, and then we can say 9 minus 0, which gives us minus 2 over 9 as our gradient. And in previous lessons, we said, well, once we've got the gradient of a line, all we need to do is put that gradient into the standard form. But then there was one more thing we need to do. We need to choose a point on the line to help us. Or we can notice something. We can notice that this point over here is the y-intercept. And isn't C the same as the y-intercept? Okay, I'll wait a little bit before I get the final answer. Okay, so I think a lot of students will probably just choose one of the 2 points to sub in. If you choose to, some of you will notice straight away that C is 2 because C is always the y-intercept. But even if you get stuck and you say, okay, cool, I need to sub this point in, well, what's going to happen is you're going to get, if you sub this point in, you get 2 equals, and anything times 0 has no effect. And so you see that C is 2. So in closing, y equals minus 2 over 9x plus 2 is the equation of this particular graph. Okay, now the big question. If we look at these 2 lines, line 1 has an equation of 3x minus 12. Line 2 has this equation. How are we going to check if these guys are perpendicular, and are they perpendicular? I want you to tell me. So these are the 2 lines you should be focused on. How do you know if these 2 lines are perpendicular? Hit mute all there. Just, I think there's some feedback on the line. On fire. So what we need to do is the gradient of the first line is 3, and the gradient of the second line is minus 2 over 9. So what do I need to do? I need to multiply them together, and what do we get? So we get 3 times negative 2 over 9, and I do not get minus 1. I get minus 2/3. And so these 2 lines are not perpendicular. Okay, so most of the examples so far haven't been perpendicular. And so that's fine. But now let me actually, before we have our brain break, let me show you a situation where I know lines are perpendicular. Oh, Taylor, I see your question. So if I said to you, I'm going to make up a situation now where I give you a line. So a line which has a gradient of 3. If you want to know the gradient of a line perpendicular to this, a useful trick to know is that you can get this by simply flipping them over and changing the sign. So if a gradient is 3 over 1, then a line perpendicular to that will have a gradient of 1 over 3, except what's the opposite of a plus? It's going to be a minus. And what do you get, guys, if you multiply 3 by minus 1/3? I want you to try that on your calculators. What is 3 times minus a third? Okay, exactly. So just to show you, because I was a bit worried after those last 2 examples, you may think no lines are ever perpendicular. These 2 lines that have these 2 gradients will definitely be perpendicular. Just to show you that. Okay, cool. I pushed you a little bit long. I feel like we need a brain break. And so if you guys, we'll do 2 little bits of brain break. The first one is going to be another one of those puzzle questions you like. And so I want you to try and solve these 2, and then we'll do a physical brain break as well. So what is a triangle minus a star? I try to be a bit creative this time. Would anybody like to explain this one? I feel like this one you need a bit of explanation. Who's feeling brave enough to explain? Izza, do you want to, I'm going to unmute you. Do you want to come online and just explain how you did this one? Go ahead, Izza. Or did I not unmute you? Let's see. I thought I did. Yeah, go ahead, Izza. Can you hear me, Izza? I can't hear you.
Ezra, we can't hear you. Do you want to speak a little bit louder?
Okay, otherwise, I'll unmute Kitty Bona. I think Kitty Bona's also got a answer. What did you do?
Okay, hi, sir.
Hello.
Okay, so I said the triangle is equals to 2 because 2 divided by 1 is equals to 2. And if you put it the other way, you're just going to get half, right?
Yeah,
So
exactly.
2 multiplied by 1 is 2. And then 2 minus 1 should give you 1.
Yeah. So perfect. The really important thing was just to realize that 1 was the magic number that you needed. That what's the only number when you divide and times by the same thing, you get the same answer. It had to be 1. Perfect. Well done, man. That was great.
Well done, everyone. And well done, Ezra, for trying to answer the question.
I feel
Well
like
done.
you need one more just to, we'll give up. We won't do a physical brain break today, but we need to do another one of these. So what is a clock times a soccer ball minus a fan? And then see who can do that. Okay, so Ayabonga, I agree that the soccer balls have to be 6.
First clue, guys, let's go.
And then the clocks have to be what? They have to be 3. So we've done, this was a 6, this was a 3. Now what do the fans have to be? The fans have to be, okay, be careful here, something times something minus something. The fan has to be 3. Yes, that got me a bit. So the fan has to be 3 times 3 minus 3, so that's 3. So then the final answer is what? Sino, I agree. It's 16. No, wait, no, it's not 16 because 3 times 6 is 18. 18 minus 3 will be 15. So loads of you got that. So shout out to all of you who got that right. I see Cameron, Lorraine.
That was sneaky for me, guys. I was a little bit like, what? What?
I saw the fans caught me. The fans caught me. That was the thing that got my attention. But I feel like the more you do of these brain things, the easier it gets. I don't know if you're finding that. Like the first time I looked at them, I was like, what's going on? And now my brain's like an auto-predict a little bit.
Yeah, I agree.
Cool. Okay, cool. Last bit of the lesson, guys. Let's go back. So we were doing perpendicular lines, and I want to ask you, let's just look at a different type of question here. I want you to write down the equation of a line. Now, there's multiple answers to this. Write down the equation of a line that is perpendicular to y equals 2x plus 3, and just pop it in the chat. So any straight line that is perpendicular to this straight line. And all I'm going to say is the main thing that makes lines perpendicular are their gradients. And I want to see how many answers you can come up with in the chat. There is definitely more than one way to do this, but there's one really important thing you need to realize. So let's see in the chat. Okay, so many of you are realizing negative a half, but I want to see write down the equation of a whole line. So I agree, what else do you need to add? Okay, I think I see some of you with it there. So as long as you got your y, that's fine. You need to have negative a half as your gradient, because if your gradient was 2 to start with, the gradient of a perpendicular line is just going to be the negative reciprocal. So you flip it over, 1 over 2, and then a negative. But then you can choose whatever C value you like, as long as you have some, well, I suppose you could have just left it like with plus 0. So you could have plus 2, you could have plus 3. But as long as you've got your gradient is this negative reciprocal, those two lines will be perpendicular to each other. If we draw them, they will have this relationship where the one is positive and the one is negative, and they look like that. Okay, now getting a little bit tougher. Write down the equation of a line that is perpendicular to this line, but goes through this point over here. And I want you to think, what information do you need to take from the yellow one? And what do you need to use this for? If you are stuck, I would love to have a conversation with you. Just put your hand up and we'll unmute you. But for now, I think a lot of you can try and do this by yourself. So write down the equation of a line perpendicular to the one in yellow, going through the point in blue. Aha, I see, Seth, you are on fire tonight. Give it a moment or two more, then I will give some feedback. So I think it's really important that you get the gradient from the yellow one. And what is the gradient? It's a half, which means the gradient of the line perpendicular to this must be 2 over 1 negative. So that's where you need to, but you need to carry on from there. What else do you need? Let me get blue. So for those who recognize 0 minus 1 as the y-intercept, the question is over chop chop. But I'm just going to do this method because I know it's super reliable. And again, there are other methods that you could have done too. But basically, I get that point, and then I just need to find out what my C value is. And the way I do that is I put minus 1 into y, minus 2 times 0. And so C should be equal to minus 1. And the equation of the line should be minus 2x minus 1. Okay, give me a thumbs up if you felt okay with that. Give me a thumbs down if you felt not so good with that. Because I want to see how, if this is making sense, or I'm hoping that you'll see a lot of similarities with the parallel lines part, except that instead of being the same gradient, the gradient is just a negative reciprocal. Okay, I went a little bit fast there. Okay. All right. I'll slow down a little bit. So let me just point out the important parts of this question. So I needed to go from, first of all, I had to recognize that the gradient of the yellow line was a half, but I was looking for the equation of the line that was perpendicular to this, which meant that the gradient of the line I was looking for was -2. Now, the line I'm looking for at this point has some of its identity, but it's missing a C. So basically, I've got this bit here, but I don't know what C is. And so in order to find C, what I do is I take the point that was mentioned earlier and I sub it into this equation. So you'll see this is a X and this is a Y. And so in the next line, where there was a Y, all of a sudden there's a -1 because it comes from here. And then from here, there was an X, there's a 0 over here. Now, -2 times 0 is nothing. And so what you're left with is C must be -1. And so that was all I was looking for. That's what I needed from here. So my final equation is -2x -1. Okay, if you're still struggling, don't worry. We're going to do another one. See if you can do this one. Write down the equation of the line that's perpendicular to this line. But I want to point something out. This is not in standard form. So you need to think about, if it's not in standard form, what does that mean? Okay, over to you guys. And if you are getting confused, yes, I agree with you, Linda. Either raise your hand and we'll have an audio chat, we'll unmute you, or tell us where your confusion is happening and maybe we can help you. Because I'd love to help you if I can, but it's hard if I don't know exactly where I'm losing you.
So I have a question from Eza. Eza is saying that he's getting confused into finding the gradient. So I think maybe just noting those points down.
Okay. So let's talk about, like in this question, there's an original line in green, and we need to know what the gradient of that line is. But the problem is it's not in standard form. So the first thing you have to do is rearrange that into standard form. And so if you rearrange it, to me, that means the 1 must come to this side. Oh, that's too big. So the 1 must come to this side. Sorry, guys, these are all just pens are like huge. And the Y must go to that side. And if I do that, I should get the equation of my line is Y equals 3x -1. Give me a thumbs up if you see that the green line can be rewritten as Y equals 3x -1. I just want to know if you can get that part. Okay. Now, if it's rewritten, that means the gradient of the green line is 3. But that, guys, is just starting the thing, because, for example, this line in red with a gradient of 3 may look like this. But what I'm after is the equation of the line that is written in blue. And so now what I need to do is, I know that this line in blue goes through the point 0.9, right? But I need to know what the gradient of the blue line is. And because it's perpendicular, we know the gradient of the blue line is going to be 1/3 negative. So now I'm still not done, but at least I know the gradient of the blue line. What I need to do is I need to use my process for finding the equations of straight lines. And what I always did was I know that, but the problem is I don't know what this is. So in the chat, how am I going to find C now? What is the thing I have to do in order to find C? There's like a step that I did in the previous line. And I want to know that you know what it is. So I have to take that point. I have to substitute. Yes, I have to take the point, and the only point I'm given is 0.9. And so let's substitute. This is y. So 9 equals, and this is going to become a 0. Good news is that 0 times anything is nothing. And so, oh yes, well done, Sihawu. That's correct. The equation of the perpendicular line should be minus a third x plus 9. So guys, if you could just give me a thumbs up if you feel a bit more comfortable, and a thumbs down if you still feel very confused with this type of question. Just so I have a feel for how the students are doing. Okay, fantastic. Let's do one more, or let's try and do 2 more, and then we'll call it a night, because I think we've done well. I want you guys to do this. A straight line is perpendicular to this line. It passes through that point. Find the equation of L. Oh, I see lots of, Yolanda, is students feeling a bit more confident now? Is that what you're seeing as well? Okay, I see a question. So Susanna, go ahead and unmute yourself, and I will, I've asked you to unmute, I think, or at least I'm trying to.
Sorry,
there we go.
Excuse me, sir. For the
Yeah.
previous question, can you please show us how you would have gotten the answer using the other method, like the y minus y1 equals?
I can. Let me just try and remember it while I do it. So in the previous, let's go get it quickly. I'll remember it. It was minus a third, and the point was 0.9. Okay, so I'm doing this question. This is from the previous one. Are you happy that you have the minus third, Susanna, from the previous question?
Yes, sir.
So what you have in the other method is you always have a y minus something and an x minus something. And all that's going to happen is you're going to go x minus 0 because of that, and then y minus 9 because of that. And so then what's going to happen, this is the previous question, guys. I don't want you to get confused. Just carry on with the other one there. This minus 9 becomes a plus 9 on this. Actually, wait. X minus 0 is just x. So this has no effect. And so you have minus a third x on this side. And then all you have on this side is your y minus 9. And then when you bring that minus 9 to the other side, you still get the same answer of minus a third x plus 9. Okay, is that helpful?
Yes, sir. Thank you.
Pleasure. Okay, let us have a look and see if answers are coming through for this question. So I know that my gradient of the perpendicular one is going to be minus a half. So that's step 1. And then I'm going to use that to say this. And then I have to ask myself, I need to find what C is. And the way I find C is I substitute in the point 10, 3. And if I do that, let's make sure I put them in the right place. But I get 3 is minus a half. Okay, let's just make sure I make this right. And then this is going to be 10 plus C. And then 3, now what's minus a half times 10? It's minus 5 plus C. And then in order to get the c by itself, it's this -5 that's getting in the way. So I'm adding 5 to both sides, or some people would say you move it over. And if you add 5 to both sides, you should get 3 plus 5 is c, which is 8. You get -1/2x plus 8. Okay. Thumbs up if you feel okay with that. I want to squeeze in one more, just one more, and then we're done for the day. Just so okay. Fantastic. Well done, guys. Okay, let's squeeze in one more. Then I promise we're done. Don't need that one. Okay, let's finish with this one. A negative. That's it. So the straight line K has this equation. The straight line J is perpendicular to K and goes through the point like this. What's the equation of J?
Let's do this, guys.
Let's go out with a bang.
My computer just crashed and I was out for a minute.
All right, we're so focused on the job. We're like,
Yeah, so.
Bukhlali, I'll do a quick example of nature of the roots after the section. Just a very quick example, yeah. I'll see what I can do to help you out.
Wow, you guys are awesome. Ah, those answers.
Keep them coming. The only thing we have to be very careful of is the double negative. So be careful of, I think a lot of you are comfortable getting -1/2. And then you put your -1/2 here, and now you take your point and you put the x in the right place, you put the y in the right place, but be careful because -1/2 times -4 gives you +2 plus c. And then when you find what c is, you take away 2 from both sides, you get 8 minus 2. So c should be 6. And the final answer should be y is -1/2x plus 6. So that is the equation of the line perpendicular to K. All right, guys. So I think that we have done so much work tonight that we can call it a end of the lesson. I just want to get a quick poll on how you felt about the lesson in terms of pace. And if you have a moment, if you could fill it in. But after you filled in the poll, I declare class over. And I just want to say, yo, well done. I thought you did really well today.
Yeah, well done, guys. Woo, that was good.
Covered quite a lot of work, yeah.
Bye, Levato.
Okay.
Seth.
Yeah. How's it going?
He says that he has an answer for the yellow block. Our little fun exercise.
Yellow block.
Yeah.
All right. Oh, yes. Okay, the one, the math 24 at the beginning.
Yes, that one. Good night.
Cool. All right. So stay on the line. I'll just help Bukhlali very quickly as best I can. I think we've lost a few students a bit. The poll hasn't had we only got 65, but I think we'll go from there. But let's have a look. Okay. Cool. All right. Cheers, everyone. Bohlale, if you just stay on the line, I'll do what I can to help you very quickly. I can't spend too long. Thank you, Yolanda, so much. I'm just going to quickly, I'll just explain something very quickly about the nature of the roots. Cool. Cheers, everyone.
Bye, guys. Everyone who's still doing the pace, please do so before exiting my English.
Cool. So a quick look. Nature of the roots. What do you want to know about nature of the roots, Bohlale? Maybe you want to unmute yourself. Raise your hand and I'll just take a quick question.
Say I do not understand the nature of roots at all.
Okay.
Like, I always get them wrong in class.
I'm only going to tell you two things. The first thing is nature of the roots come from the quadratic formula. So you need to understand what the standard form of an equation is. Do you understand that?
Yes, I understand.
Okay, now there's something called delta. And delta comes
minus 480.
Yes. And delta comes from the quadratic formula. So it's this little bit over here that's hiding in this bit. Okay, now what you have to get comfortable doing is if you've got an equation like this, or basically, if you want to find delta, you need to know how to use the A, B, and C. And then use a different color, in fact, from here. So let's say, so whenever you do a nature of the roots question, this is all I'm going to tell you how to do today. You always find delta. In this case, delta would be 2 squared because it's B, that's A, that's C, minus 4 times 3 times 4. And so in this case, delta would be 4 times 3 is 12 times, so minus 48. So we would say in this case that delta is negative 44. Okay. Now what that means in the nature of the root section, depending on what your delta value is, you can classify the roots of the equation. When delta is less than 0, we say the roots are non-real. Okay, but all I'm going to say to you, I will help you where I can along the way, but for today, I want you to practice finding this thing called delta, and you must be able to get that done. Okay. That's the start of the section. All right, Yolanda, I think it's time for us to wrap up the show.
Yep.
And thank you, everyone. I enjoyed teaching tonight, and we will see you on Wednesday.
Thank you.